previous recordings, catch up what was left out, then prepare for your assignments. Okay, there won't be any extra time allowed to the wildcat entries. All are expected to submit the assignment by August, whenever the time is announced. I'll be announcing it prior 1 week, and you will be expected to submit on time. And you don't have to wait till August to submit your assignments. You can submit it before August too. We'll be correcting it. We'll resend the corrections. You can make the corrections and return to us back. Now, August will be the final submission date. Whatever condition we receive the file, that it will be evaluated as such, and the marks will be taken based on that particular file. If you want it to be corrected earlier, if you want to correct your errors, then you will have to do it earlier than that. Okay. Now, I suppose I am clear with the assignments. Now, let's start with today's session. Now, when coming on to the project management side, we'll have 4 main areas we'll be introducing you to. The first one will be bar bending schedules. The second will be optimization. What it will be, you will be learning in the way. And the third one will be estimation. So estimation, you have heard, you will be doing it with the help of a software. And you will also know the traditional way also. And finally, and the most important part, enterprise resource planning, that is ERP based websites. You will be dealing with an ERP wherein you will be creating a project, managing the entire project, planning the same using that ERP. ERP is not a hectic thing. It is user-friendly website wherein you will be managing a project online. Okay. Now, these are the main areas you will be dealing with when you're learning or undergoing the project management training. And for today, we'll be starting with the bar bending schedules. I'll be sharing my screen. Now, before starting the actual presentation, I would like to give you some insight into what bar bending schedule is. Have any one of you seen a bar bending schedule earlier, beforehand, before in your lifetime, wherever, by instance, during your internships or something? If so, just raise your hand. I just want to know if anyone has seen or worked with a bar bending schedule earlier during your internships or any by coincidence or something. You can say, you can share the same here. I don't want you to explain anything or something. Who is that? Sajna. Okay. Have anyone else? Okay, I think only one person is knowing what it is. So for the rest of the audience, bar bending schedule is more or less like a table. A table which contains, I'll just show an example, a table which has the size, shape, length, and such information regarding the bar to be provided as reinforcement in a concrete structure. Looking at it looks boring, right? It's not actually that boring. It's a real interesting part of structures. Now, how it is interesting? If we remove the frame from our body, that is our bones from our body, what is remaining? Some flesh, fat, and skin. That's all. It can't stand, it can't walk, it can eat, it can't do any of the activities without the framework. Similarly, a structure, an RCC structure, is only capable of taking the load when it has a framework, a reinforcement. So framing or reinforcing concrete enables it to take loads other than compression and keep the building intact. So what is the importance of a reinforcement? It keeps the RCC structure intact and aids it in carrying the load. So it is the most important part of an RCC structure. Now, how can we make it more interesting? How can we work with it more interesting? It is by visualizing. Why and how and where you are providing reinforcement. Now, the visualizing part is involved with designing part. That is where you decide what is a main bar to be provided, die of main bar, spacing of main bar, number of main bar, length of main bar. All these you are designing in the structure design part. Once structure designing is completed, the output looks something like this. So after structure designing, a structure designer often shares a drawing which looks something like this. If it's a slab, there will be rebars marked. The spacing of bars will be marked in it. If it's a beam, if you look closely, it will be a beam. It has the spacing of stirrups will be given. The main bars are marked. So that is what a 2D output we get from after structure designing. Is it sufficient for implementing inside? If you give this drawing to a labor or a helper or a mason working at site, if he is if he has years of experience, then he might know what this 2 stands for, 12 stands for, or 5,000 stands, 500 stands for. But a new person, a fresher, he or she would be taking a lot of pain and time to understand what is shown in this drawing, what exactly it is, what this line means, what this line means. These lines will be confusing him. And this is not how he gets a drawing. He would be getting a drawing just like this. He'll be getting a drawing which looks more or less like this. What will he understand from this? Nothing. He won't be understanding anything if you give a drawing like this to him and ask him to create the rebar cage. Then he or she won't be able to do anything about it. That is where the project management side gets involved and helps them do the work simply, in a simpler manner. Simply means in a simpler or broken down manner. So there we supply a table where length and bending, how much it should be bent. So the length of bar is 3,250. Then he should have make a U-shaped bar from it by bending 75 on either sides. All these values are in mm, not in meters or centimeters. It is in mm. So easily he can understand, oh, on one side I should have bent 75, other side I will mark and bend 75. With that, he can easily bend the bars. Now that is the main and most relevant part of bar bending schedule. You should give a document to site which can be easily read and understood by any person in the site. You should not give something that is confusing or misleading that person. You should give the most simplest thing to site so that he or she can work with it and produce a proper framework. If you're designing a building proper, it is capable of standing for 100 years and 1,000 years and all. But when it comes to the site, if that person who is actually preparing the rebar cage, if he is not able to cut the bar properly or assemble the bar properly, what happens? The strength of the structure is completely destroyed. What you expect to stand for 1,000 years will not even stand for 10 years. That is a difference. What happens or what affects when the bar bending schedule is not properly executed inside. Okay, now how can we make it simpler while preparing this bar bending schedule? Even we get confused how to give the bar, how to draw the bars, how to how to prepare the schedules in a simpler manner so that both us won't be making mistakes and they won't be making mistakes. Before that, we'll just go through a few bar bending schedules just to see what it is and how it works. Now, this, as I said earlier, this is a bar bending schedule of a footing. The dimensions are marked, the bar shape is marked, the spacing is given, which is now they'll be laying the bars and tying as per the spacing and how it's shown in this image. But to identify which bar it is, you can use this bar number. So bar number 601 is provided from this end to this end. That dimension indicates from which end to which end we are providing it. That is how a bar bending schedule is read. Now, how to cut the bar? Usually the lower standard or less experienced workers will be low category or less experienced workers would be cutting and bending bars. So for them, this table will help them to understand how to cut, bend the bars. And from this, the mason or the higher experienced person will lay and tie the bar, lay the bars in position and ask them to tie it on position. Okay. Now coming on to the column, it looks inverted. Don't worry, it's a drawing. That's why it's kept horizontal. Actually, it is vertical. Now coming on to the bars. Here you can see a different shape of bar, not the usual straight bars. You have L-shaped bars, the lapped bar. These are for lapping of bar. So why do we need lapping of bar? When you go to a, a wholesaler or dealer who sells reinforcement, they will be selling to you bars either as 12-meter long or they will be giving us cut shape bars. Cutting bars are nothing other than if you give them a bar bending schedule, they'll cut the bar, arrange in packets and supply to you. So all you have to do is take them, place in position, tie them together. So that is cutting bar. If you are not having any proper bar bending schedules, then what happens is that you will have to purchase the 12-meter bar, cut it at side, bend them manually and use it. So this is a lapping bar. So if the length of beam or column or any other reinforcement RCC structure is more than 12 meter, what will you do? You won't be able to get a bar longer than 12 meter. So in such cases, you will tie two bars together to get the length. And for that, you will be providing a lapping. So lapping is done using this shape of bar. It is actually a Z-shaped bar. I'll just show the AutoCAD file, which is helpful in understanding the shape of bar. You can see an L-shaped bar. I need a lapped bar. Oh, I think you're unfortunate. There's no, yeah. Now this is how a lapped bar looks. This is the end bend length you're providing to get the development length. Okay. Now the next part. So that is how there are wide varieties of shapes over here when you think about a column reinforcement as well as a beam reinforcement. Now you can see that column rebar ties, they have to be properly detailed. You have to give the hook length, angle values and all properly. Otherwise, while implementing, they might get it wrong, which in turn affects the strength of the structure. Now, this is the bar bending schedule of a beam. I know it's lengthy, but it's actually required for easy implementation at site. Now, I think you have noticed there is an extra table in each of these BBS files. The table is nothing other than weight details. Now, what is the relevance of this table? When you purchase steel, you actually purchasing it in kgs or tons. So when you want to purchase the same, you will need to know how many tons of steel you have to purchase. Of 25 mm diameter, you need so much of weight. For 8 mm diameter, you need so much of steel. So in order to understand what is the amount of steel to be purchased, you need to know the weight of steel. So along with bar bending schedules, it is necessary to calculate the weight details. And don't worry, you can do all these in simple way by using a software. That is what you are going to learn, how to simplify the procedure of preparing a bar bending schedule. Now here, the weight details I have discussed. We'll get the weight of, we know to calculate the weight of one bar, you have to use the equation L d square by 162. From that, you can calculate the weight of a total length of bar and you will get the total. Now coming on to the next part, we have here. Now, all these are straight bars. Where we usually find a lot of straight bars in a slab. In all of the structures, you get a mix of stirrups, straight bars, bend up bars, etc. But when coming to a slab, you have a mix, only a series of straight bars and just U or L shape bar. No complex bar shapes, only simple bar shapes coming up here. Then coming to the next era of bar bending schedule. Now, all you have seen is a 2D boring bar bending schedule. Bar bending schedules can actually look as interesting as you see here. Now, this is a bar bending schedule for a pile cap and pile reinforcement. You can see the actual 3D image of rebar cage here. Let me zoom in for you. You can see the stirrups in either directions, the horizontal reinforcement, the vertical reinforcement, how the pile cap main bars are ending. Now, this is the future of BVS, and you will also get a glimpse of the same while you are learning BVS along with us. Now, there are varieties of pile caps over here. This is a double pile cap. Now, the rebar cage. You can see the rebar cage over here. You can go to this level of bar bending schedules, which is going to be the next era in bar bending schedules. And you, as I said earlier, the table is inevitable. You need a table so that it can be easily cut and arranged by the workers who don't have the knowledge for interpreting complicated or sophisticated drawings. But even if a worker is seeing this, he would be able to grasp what is given, what is to be made, what is the shape of the bar. They can actually understand what is to be done. So this type of representation actually helps even everyone involved with the process of implementing bar bending schedules. Even structure designers can decide whether to use this shape of bar or whether to go for this reinforcement. What will be the how congested the rebar cage will be? Will it be easy to implement it inside? All these factors will be dealt with. Okay. Now, this is a new era BVS we are working on currently. Now, as I said earlier, bar bending schedule is not a boring topic. It's actually interesting, but you will have to put your interest into this. You will have to know what a framework is and how a reinforcement has to be provided in order to draft it and prepare the BVS. Okay, now I'll just show the models for you. Go on to the 3D of this particular cell. I suppose you can see the rebar case. If it's not visible, just let me know. Okay. Now the same rebar case which I showed you, I just highlight each bar for you. Now this is a stirrup provided or the vertical reinforcement provided in shorter direction. This is a longer direction, upper top bar. It's a U-shaped bar. As you can see, it's a U-shaped bar. Don't worry, this is a wireframe. That's why it's overlapping here and there. Now it's a top bar. Now you can, I'll just highlight the bottom bar. Now the bottom U-shaped bars. Then we have the side face bars. Why don't I provide stirrup-like shapes over here? It's because the dia of bottom bar will be higher than the dia of top bar in the case of a pile cap. So I can't provide a continuous reinforcement. I'll have to provide two different size reinforcement in top and bottom layers. Okay. If it was the same and the size of the pile cap is not that large, then I can go for stirrup shaped bars in all three directions, just like in this one. So here we have bars in all three directions like a stirrup. So if it's huge, then it will be difficult for the workers to bend, carry, or place and even tie the bars. That is why we are cutting it into simpler shapes so that they can work with it easily. So I suppose I'm clear to you regarding the main purpose of bar bending schedule. That the main purpose of bar bending schedule is just simple. You will have to make a schedule which helps providing the reinforcement correctly so that it carries the load, and secondly, it can be easily implemented in the site. These two are the main purpose and main focus of every engineer who works with a bar bending schedule. Now we have column. I'll just go through a column rebar model for you. Okay. Now this is just one column, not the entire building. Now this was a column which has a orientation shift. I'll just show a view to help you out. Now look, the column was in facing in into the screen in the in the ground floor, and when it came to the first floor, it was just rotated. I'll just show the top view for understanding. Now here, initially the column was facing in the in the other direction, and later on it was shifted to the other direction. Okay, I suppose it's clear, or I'll just show the drawing. Okay. Now initially, as you see in this image, initially in the ground floor position, it was like this. The 200 was horizontal and 300 was vertical. But later on, it was rotated like 300 horizontal and 200 vertical. So the rebar modeling was done in order to understand where you have to end the bar in the first floor and where you have to start the bars in the ground floor. Okay, how to end the bars in first ground floor and how to start the bars in the first floor. Now that was what we are modeling over here. So even bar bending schedule is an interesting topic. When you try to involve with it, you will have to know how to provide the framework in order to keep the rebar in position, to make it carry the load, and it should satisfy the structure design also. So all these factors should be kept in mind, and you will have to work with it. Now that's the basic introduction part of BBS. Now let's come to what our main part. Now, as you have gone through a lot of case studies, I suppose you know what's the use of bar bending schedule. It is used to help the workers cut, bend, and tie the bars in position. That is the implementation side use of bar bending schedule. When you come to the design side, as I said earlier, to detect clashes, how the rebar cage looks, all these are other factors, but not the main or important factor. The main factor is that whatever is designed should be implemented inside accurately so that the structure stands intact. So there are 3 steps: cutting, bending, and tying. Now, importance of bar bending schedule, we have already discussed this part. I'll just go through it. Any error would result in poor reinforcement of section. So it would affect the strength of the section. And it will also affect the durability. If you're designing a structure for 50 years, what is intended is that by 10 years only it should show some deflections or cracks, so that you will have to repair it and keep it intact. If the building starts showing some cracks or sways after 1 year, it clearly shows that the building is not able to take the load or stand properly in that or is unable to withstand the loads acting on it. Now, and the last and most important part is to control wastage of material. Why is wastage of material so important? I'll just explain with the help of an estimate. Now, as per an estimate taken by us, this is a 20,000 square feet. 20,000, no, 2,000, sorry. 2,000 square feet building, and the amount of steel used in one floor. I'm saying that 2,000 is the area of one floor. So one floor has 2,000 area, and it's 2,000 square feet area, and it consumes nearly 4.5 or approximately 5 metric tons of steel. So 1 ton of steel costs nearly 90,000 rupees. Just zoom it in so that you can see clearly. Okay, so one floor has nearly 5 tons of steel consumed, and the cost of 5 tons of steel will be nearly 4 lakhs. So 4 lakhs is not a small amount of money. Anyone losing nearly 1 lakh in their project will surely blame the project manager. So what we will have to do, we will have to cut down the wastage. And for cutting down wastage, you will have to use bar wisely. And for wise use of bar, what you will have to control, you will have to control on how it is cut, how it is bent, how efficiently it is arranged, how in the design, from the design side to the implementation side, everything must be checked so that wastage of steel by over reinforcing, by cutting. All these are avoided. So that is a very important part. Now for small projects, it's maybe the wastage is considerably lower. But when we go for a project like the Lulu Mall or uh, or the Metro Rail or even projects like that, which uses massive amount of steel, then the figures won't end in lakhs. It would be going up to crores even if we are not properly controlling the wastage. I'm talking about wastage, actually, not the project cost. I'm talking about wastage. If you don't use steel wisely, you are going to end up with a wastage that is going to multiply the cost of your project. So the main part of a project manager, or the main thought of a project manager is to minimize the wastage, work the project, complete the project on budget, and make the client happy. So that is the main focus of a project manager. And to get that goal, what we do is we provide proper bar bending schedules, which helps in cutting the wastage. Now back to our presentation. Now it affects the project cost. That's what I was explaining. Now the first step, cutting of bar, and the next step is bending. Then comes time. Cutting and bending can be implemented manually or by aid of machines. As I said earlier, you can purchase a 12-meter length bar and cut it on your own, or you can buy cut lengths. Like this bar already which is cut and bent to the required shape. Usually stirrups can be bought in that manner. If you have a proper bar bending schedule, you can issue the same and get all the bars cut so that the wastage will become zero. If you have it properly done and share to them, you'll have zero wastage. You can make it the wastage to zero if you're having a proper bar bending schedule. Now that is nearly a big success for a project manager if you can make the wastage of bar to zero. Now on site, we usually prefer manual means, and there are some machines which help for on-site bar bending and cutting. These machines, we don't prefer bulky machines for on-site purposes. Off-site purposes, we have fully automated bulk machineries in factories and all. Now, the traditional method of bar cutting, either you use manual cutting machines like shown in the figure, which has a lever and cutting edge. You'll be applying manual force to cut the bars. This is a traditional method we use for small sites where the budget of project is not that higher. And in case if the amount of steel to be cut is more and you have a large area project, you will obviously have to go to a mechanical means in order to speed up the process of preparing rebar cages. So for that, you'll be using something like this. It's called a cutting machine, electric cutting machine. So it will be powered by electricity and be used for cutting bars of even higher diameter. Like it is easy to cut a 10 mm dia bar than when we compare to a 40 mm dia bar. So for higher diameters, I would say it is better to use a cutting machine rather than depending on manual labor. And the next part is the bending part. So before this, let's see a video on how bars are being cut inside. So I don't know how many of you have been for a site visit and have seen this same. So I'll be just showing this video so that you can relate to. Now this is how the person is manually bending a bar. Now they are applying manual labor. There are two people involved. So it is taking energy of two persons, and the time involved is also higher if the diameter of bar is increasing. So they'll have to bend all L shapes, U shapes, stirrups, etc. this manually. Now there is three people involved because the bar dia is more, the length of bar is higher. So it will be involving more people. Now when we look into the machine method, you want the screen to be larger. Now this is a machine. This is a demo video of a machine which is used inside. Looks like similar to your compression testing machine, something table type machine which is compact enough to be carried to a site. Now this machine, you can see the operation. Once the power is on, and the rebar is placed, it will be you just have to push the bar in position. It will be automatically. This is a 42 thick bar they are representing in the video. You will have to you can bend it in different methods. You can even go for more number of bars at a time bending when the number of bars is more to be bent. So it saves time, saves energy, and only one person is required to operate and place the bars in position. Okay, it will be easy, fast, and you'll get all the work done. Now let's go for the next video. Now rebar. Now that was about the cutting and bending part. Now, as we saw in the video, when our person is working with rebar bending manually, he'll have to use a lever, a 3-pin, and in order to bend the rebar. This is a lever. They call it a lever, which is used for bending or applying applying the force in order to bend it. And a 3-pin is just a small device used to help bend the bar in the required angle. Now this is regarding. I'll share the PPT so that you can go through the videos also. The links will be given along. And this is just an image of how it's shown. We actually saw the video, so I'll be skipping that part. Then tying of bars. So we went through cutting, bending, and tying. Now for tying, the traditional method was to use something as shown in this figure,
Yes,
which will be
ma'am.
used. I'll share the links of the videos too. I'll share the link of the videos in your groups, I guess. That would be better. Let me see if I can join some way. Okay, we were discussing about the okay, we'll just go with Steffi's screen. I'm not able to log in with any other. Okay. Now, Steffi, can you go for the presentation mode? Just go with presentation. Have I shared the PPT file or just that? Okay. You can go for presentation. Click on play, but play option in order to get the presentation going. Okay. You can skip a few slides. How to use, how to cut, all these were explained already. Importance was already covered. Then the importance part, okay. Then the, okay, from, I think from this part you are missing out. This slow, go slow, go back. Now, as I said earlier, the amount of steel wastage itself decides the budget of the project. Okay, now for benching and cutting, the cutting methods, this is a traditional method where we cut the bar using a tool which has a lever and a cutting edge. Now we apply manual force in order to get it cut. Now on to the next slide. Steffi, you can go to the next slide. Hello. Okay, go to the next slide, Steffi. Don't go that fast. Please go back. No, you're going so fast. I can't manage this way. I just I'll just rejoin back. Just wait for me 5 minutes. Am I audible now? Hello.
Yes, ma'am.
Am I audible now? Okay. Is my screen visible now? Okay. I suppose my screen is visible. Steffi, is my screen visible?
Yes, yes, it's visible.
Okay. Now, where we stopped actually was where I was showing the estimate side. And I did say that we require nearly 5 tons of steel, and the wastage side was already explained. Now, coming to the implementation and importance part, that is where I think we have you seen the importance slide and all shared? I think we can go skip that part for the right now. We'll go to the bar cutting and bending part. Now, as I said earlier, in order to implement bar bending schedule inside, it involves cutting, bending, and even tying the bars together. And for that, you have inside, you can do manual bending as well as machine based cutting and
Ma'am,
bending. Yes.
it is not still visible for us.
Steph, it's not still changing for you?
No, it's visible for me. Yeah, it's changing for me.
Okay. Please check your internet connection too. I had some errors while using Teams. So maybe it's an other issue. Okay. Now, I'll just go for the slideshow. Now we'll
Ma'am,
just,
not visible for
yes.
me.
Can you all just, those who have issues with seeing the screen, just leave the meeting and rejoin. I'll wait for another minute. Okay. If it's not visible for you, or I'll just cut. Okay, just leave and rejoin. Try leaving and rejoining. We'll continue with the session because it's already recorded. So they can just go through the recording because we are almost delayed by 10 minutes, 10, 15 minutes. So I just want to catch up. Can I just continue? Those in the meeting, can I just continue?
Yes, ma'am.
Okay. I will just have them watch this recording. Okay. The bar cutting and bending side, as I said earlier, on site we can do manual and machine aided. Off site you can go for automated or in factories. So the entire thing will be cut, bent, and supplied to in packages. You just have to unpack them, arrange in your rebar, arrange to form the rebar cage, and tie them together. Now on site you have the traditional manual method and the machine aided method. Now coming on to the manual method, wherein you are using a lever and cutting edge based machine. Here you will have to place the bar as shown in this image, and he'll be applying some manual power in order to shift the lever from first position to second position, and will be cutting the bar. Now this is a manual method, and for it is not recommended for bars with higher size. Just go for bars of syrups which are 8 mm or 10 mm, and there too I would say this would take more time. Use this for projects which are very small or requires less amount of cutting and bending. For projects with larger area like 1,000 or 2,000 square feet building, go for machine aided cutting, wherein you can use electric cutters as shown in this figure. You have different types, the one which can be kept on a platform or which can be operated by hand using a by hand. Okay. Now these are usually adopted for cutting when there is large quantity of steel to be cut and when the diameter of steel is higher, like more than 12 mm, more than 16 mm, more than like 40 and all. So in such projects, I would recommend go for cutting based on machines. Now coming to the bending part, not just cutting is sufficient. You will have to bend it into U-shaped bars, L-shaped bars, or any other bar as per the bar bending schedule. And for that, you can either use manual method or use the machines. Similar, like in manual method, the manual method is limited to small projects with bar diameter less than 16 mm because when diameter is increasing, you will have to apply more manual labor in order to get the bars into the required shape. Now we'll go through a video on the same. Now let me play the video. Okay, as you see in this video, I suppose the video is playing for you. As per this video, you can see that there are people who are holding the bar as well as there is a lever. They are applying manual labor in order to bend the bar into the required shape. So it requires a minimum of 2 people. And as per this video, there are more than 2 people involved. If the length of bar is longer, then we'll require more than 1 or 2 person to handle the bar. Okay. And actually, this is hectic and not that recommended when there is large amount of bars being done, bent and used. Okay. Next method is a machine-based method. In this video, you're seeing a bar bending machine, which is compact enough to be carried to side using a like not manually carried. It should be transported to side using a any load carrying vehicles. Okay. Now here you have a bar bending machine. All you have to do is that place the bar of any diameter can be placed in position and bent. Okay. Once it's power on, you just require an operator who would start the machine and push the bar to positions. Okay. Even a 42 mm thick bar can be bent by this method. Then even multiple number of bars can be bent together using this method. Now that is a machine-aided method. Now coming on to the rebar tying procedure. Now, not just bending is sufficient. All you have to cut, bend, and tie it in position. Tying it in position is required for getting it properly to concrete the same. Okay, a structure once it's hardened, it will work like a framework. But in order to keep the elements or rebars in position, it has to be tied properly. So tying is not related to the strength of structure. It is related to strength positioning of reinforcement, which in turn helps in increasing the strength or maintaining the strength of the structure. So tying bars together does not involve a heavy or large element. Like you're using a simple binding wire, a small wire. Compared to the size of the bar, the wire size is very negligible. Such small size wires are used to bind the bars. So you'll be wondering, what is its purpose? The purpose is only to hold the bars in position. It is not contributing in the strength aspect of the building. Now coming on to the tying methods, you have the manual tying method on left hand side and the modern method of using equipments for tying the bars. So when you have to tie a large amount of bars in the slabs or beams, you can go for the machine-aided tying for quick and convenient completion of work. So we'll see both the methods. First video will be for the manual method of tying bar. So you can see once you are experienced, you will be able to do this in such speeds. But if you're not experienced enough, you won't be able to tie it in position in the speed and in a proper manner. If it's not tied properly, what happens is that when you pour concrete, the bars would be displaced from its position. So tying is important until the concrete hardens. So the binding wire must be strong enough to hold the bars until it hardens. So it should withstand the forces while pouring the concrete also. Now coming to the automated method, you just can see that a person is just walking, and by walking he is just tapping and tying the bars. So this type of method is very convenient and effective when you're dealing with complex and tightly packed rebar cages. Okay, now that's regarding the bar tying and cutting and tying. Now coming back to our presentation. Now, as you see, before you work with any BBS element, like BBS of any structure element, you will have to understand how the bars are to be provided, where the main bar is to be provided, how it is to be arranged, how the stirrups are to be provided, what is the shape of a stirrup, what is the shape of the main bar you intend to provide. So all these factors should be known beforehand before preparing a BBS drawing. Like what is the footing, how the reinforcement should be provided, how to fan out the reinforcement, what is the angle in which it should be bent. All these should be known. How can you know it without even seeing it inside? Simple. You can go to Google, just open a new web browser, type the if you want to see the rebar cage of file, just search the same. You will have videos, images, all these supporting what and how it actually looks. So before dealing with any type of BBS preparation, just go and search images of the same. Understand what is a main bar, what is a stirrup, what is a stiffener, what is a tie, where it is provided, how to provide it, which is the optimum method to provide. This is not just for preparing a BBS. You need to know how the rebar is to be provided even for designing a structure. So this is both important for a structure designer as well as a project manager, because to make a structure strong, its cage, its framework has to be strong and intact. Okay. So before preparing any BBS drawing or any BBS document or even designing a structure, I would strongly recommend you Google a few pictures regarding the same. Try to understand how it is implemented inside, because design part is completely focusing on the budget, the structure requirements, strength. But implementation part is completely based on how can you cut, bend, and place it in position without affecting the strength of the bar. So both has to be combined and worked out to get a good BBS schedule. Okay, you're understanding it? Like you have to go think like in the structure side as well as in the project management side in order to produce a good bar bending schedule. It is an interesting job when you try to involve with the visualization of how to provide reinforcement. Unless and until you visualize what is to be done, you won't be able to work with it happily. You will have to visualize how the bar is provided in order to know when and where it has to be implemented. And the best thing is that you can Google for the same now without even the restriction. In earlier time when I was learning, I had no idea where each bar has to be positioned. But now I'm able to see and understand and model the same just by Googling it. It's made so simpler. You don't need a textbook, you don't need a teacher, you don't need anything other than your phone and internet in order to explore the immense chances of bar bending schedule. Just as I mentioned in the starting of this presentation, bar bending schedule need not be boring like a table. It can be made interesting like the 3D views as you see here. But to make it interesting, make it implemented simply inside, you will have to get into it, understand what the purpose of each reinforcement is, how to position it, how it should actually look inside, how to implement it, and think and work out a solution for this. It is more like a problem solving a puzzle. Okay, you'll know just the size of the requirement for a building. You know the size of the building. You start designing it. You start designing the reinforcement. Then you have to implement it. So for implementation, you'll have to think what is the spacing that has to be provided so that the concrete can be poured without giving much pressure or much vibrations. What is the best spacing? What is the best shape to be provided so that it can be easily bent, cut, and placed in position. So all these are to be decided it by you. And I'm sure you can't do it in one day. You will have to keep practicing so that you are getting better day by day. Now back to our presentation. Now this was just a few examples of how bars are being placed in a column footing, etc. And this is how cranking of bar is done in a slab reinforcement. All these images, as you see, is from internet. You can get n number of videos and pictures regarding the same. Just have to spend the time, have to be patient enough to learn from it. No one can teach you bar bending schedules unless and until you are have a strong willpower or strong interest to learn the same. Now coming for preparing BBS, you have two standard IS codes. The first one IS 2502 and the second one is 13920. The first one is for rebar shapes and the second one is for ductile detailing. Now these codes are really important. Try to read it and go through them. Now, what interesting part is that it gives the shapes of bars which we are using while preparing a bar bending schedule. What is the bend length? What is the arc length? What is the minimum bend to be provided? All these are clearly given in with figures and in proper tabular manner. You will just have to refer the value. How to refer, how to give, all this will be taught to you. Don't worry, you will be learning everything that is required for preparing a BBS, but you will have to spend ample amount of time and learn regarding the same. It is not easy if you don't try. The entire field of civil engineering is not easy until you try to get involved with it. Okay. Now the ductile design code, use the code of 2016. I'll share the code in your group in order for using it. And here you will learn about how to bend in which angle. Ductile design detailing is already given here. These both codes must be referred whenever you are preparing a bar bending schedule. And if you are not confirming or preparing a bar bending schedule as per these codes, it will be rejected by the person supervising inside. It will be rejected for projects like government projects. It should be approved by the government agents. So they won't be approving unless it's prepared according to the IS codes. So it's very important that you learn these codes, not by hurting them. Just know where these data is present. Just know in which page the hook length is there, in which page the shapes are given. Just roughly try to familiarize yourself with the code rather than learning it by heart. You will be able to familiarize it with by understanding where each shape is given, where bend length values are given. So try to understand the same. Okay. Now this is a basic introduction for BBS. Why an elaborate introduction? Because BBS is not not so simple as you see, but it is as interesting when you get into it. You can go for 2D to 3D visuals. You will be taught how can you prepare a bar bending schedule in 3D, how to model proper rebars in 3D. You can actually feel how it is to be implemented inside. To be a structural engineer, just designing in paper is not sufficient. You will have to come into the site, inspect whether or whatever you design is being implemented. And for coming into the site and understanding what is done, you will have to visualize the same, where each bar has to come, what is the shape of bar to be provided, what is the lapping distance, what is the minimum development length to be provided. All this needs to be familiarized, learned. Only then you can implement it properly inside. And as much as I have experienced, a person with proper knowledge in bar bending schedule is treasured by every organization. Wherever he is working, he is a treasure because he or she is a treasure because bar bending schedule is a skill that very less amount of people knows and very low amount of people implements. But it has very high advantages and it can even and change the entire budget of a project. So I would recommend highly that you find time and try to learn BPS with all your heart. Okay. I'm sorry that I took extra time and I did have to pause the presentation in between. I'll get the recording for you. And those who missed the meeting, you can go through the recording and try to learn BPS. Now, the BPS session, we will be starting with Beam BPS firstly. Then we'll be going to the slab or the other way around. I'll decide the same and let you know. And it will be completely depending on the faculty availability of faculty. One faculty when's okay, based on the availability of faculty, I'll be arranging the classes. And meanwhile, you will have to work with your structure design assignments because designing is as important as implementing.